Hello, my friends of Qatari Labs. Welcome to the third class of this course of GIS in Water Resources Management. So we are going to start with our course material. That is it's session 3 on manual. We are going to do some basic delimitation and as well some statistics or raster statistics. So this class will be, this is maybe the 10th version of this course, and we have given this course over 12 years, and I can tell you that every time we have to update our process, and since this could be the most developed course that we have. Okay, so actually, even though that the purpose is to bring in from the simple things to more complex things and the data that you will need for a numerical model, the process are simple, but it doesn't mean that that do not have an intrinsic complexity. Okay, great. So let's do our work. Okay, so we are going to do in our course, in our folder, in our course folder, session 3. Inside session 3, we are going to create a new tag that is called txt, because this what we are going to set as txt, and here we are going to create a new text document and this will be point hydrometry dot by default it's txt. Okay, by default it's txt, and there is an issue here because in Windows it actually omits the extension. In Linux always represented, but it's a txt document. Okay, if you are here with me, please open your QGIS, and then what we are going to do is we are going to transform this. Okay, so we have created okay, well, start opening your QGIS, but we have created a point, but we have to insert some coordinates on that. Okay, so in order to insert some coordinates on that, I can use Notepad, but I can also do the, how say in English, WordPad. No, this is WordPad block count. Okay, whatever, this symbol of that is the utilitary of Windows. Okay, and here we are going to use east, north, and in east we are going to use 753. Okay, this number, and since I don't want you to be keeping, sorry, this number, and I will give you through the chat. Okay, as well. Okay, great. So we can save our project. Okay, and then we can close it. Okay, what is important is that this comma appears here. Okay, and if you want to insert one, this space is actually not strictly necessary, but it will allow you to have a better view of your text file. Okay, and that's it. So we can close it, and then if we create a new project, and then we go to this one, open data source management. If you are here, please type yes 1. If you are here, please type yes 1. Okay, thank you, Manuel. This is we haven't defined, it is UTM, but we haven't defined that yet. We are going to insert the system of reference later on. If you are here with me, please type yes one. Okay, who else is here with me? Please type yes one. Okay, so we are going to insert something new here. Okay, actually this one is actually here, but well, we can also insert it here. What we are going to do, is to create. This is another way of adding vector raster mesh delimited text, and as well your, I think that here you can do your GeoNode, RGIS, vector tile. Those are different standards of the OCG. Okay, all of these are different standards of the OCG. Yeah, vector tiles and so on. What we are going to do is to add a delimited text. Okay, and the delimited text is the way where you can insert point data into QGIS. So here where we are going to go is to the course folder, the exercise folder, session 3 txt, and then here we have point hydrometry. Okay, we can select it. Okay, point hydrometry. Okay, and then you have several options, and these options are, well, they change on every version of the course. However, here we are going to use CSV file because it's comma separated. That's why the comma needs to be there. Okay, because it's comma separated. Okay, and this one has these numbers of headers. Okay, if you see, first the records have field names. Why? Because if you can see, the first line has east and north, and these are the field names, and these will be represented here as east and north. Okay, and that's it. Okay, so if east and north appears here, yeah, that's everything. Okay, and then following the manual question is this UTM? You define that this is UTM, so you define this UTM. If we are in the US, it will be NAT 83, NAT 83. Okay, well, this is coordinate geographical. It will be okay, geographic. Okay, it will be also projected. Okay, but in this case is 3271, which is this one 17. Okay, 32717. Okay, great. So this will be 32717. That this is okay. Okay, so that's it, and the layer name will be point hydrometry. Okay, that's everything I need to know, and then I just have to add, and it will add a layer with my point. So actually you only will see a point. If you see the point, please type yes 2. If you see the point, please type yes 2. Okay, so this is the configuration of the delimited text. Actually, it's pretty powerful, and I mean, you can do more stuff with that because you can also define the set values, you can do regular expressions and so on. No, it doesn't accept Excel files, because here actually you are only can work with txt, csv, or well-known text. However, you can export from Excel to CSV. Okay, you can export from Excel to CSV. Okay, great, you're doing amazing. Okay, so let's continue with our exercise. uh, we are going to save this. We are going to okay, cancel. We are going to save, export save feature as. Okay, why we are going to save it? Because right now this is just a representation of a table. Okay, you have to understand what is in which stage we are now. We have represented a table, so this table is still a table. I mean, it's not your special data, even that you see that with a projection, so it is still a table. So we have to store as a srchef file. So here we store as a srchef file, and where we are going to store is here in session 3 on the course, on the folder, exercise folder, and here we are going to create a new folder that is called shp, and here on shp we are going to call it point geometry, point hydrometry. Okay, so this is the point hydrometry, and it will keep the system of reference 32718, so 32717, so it's WGS UTM so 1817 South, and that's it. Okay, and this is a chef file, while this one is just the representation of a table. So the representation of a table that actually is, you will define it, you will recognize with, because it points to the text file, we can remove. Okay, we can remove the first one because we are going to keep the ones that we find. Okay, so then we are going to work with the geometry, with the basing. Okay, so we are going to with the basing elevation, in order to prevent some, because you might have done something different on the previous session, in order to prevent us from the course material, we can go to session 3, from the course material to practice, to data, to raster, and then we are going to add the layer. Okay, so okay, in order to prevent that you might have something wrong with the raster them, and this will also create something wrong with this class. In order to prevent that, we are going to use from the session 3 on the course material data raster, and then we have the AST-GTM2 comcat UTM com UTM. Okay, and then we place this layer below. Okay, and since you might see that as kind of very obscure like this, so you just have to do right click and then zoom to layer, and it will be like that. Okay, so if you are here with me, please type yes 3. If you are here with me, please type yes 3. If you are here, please type yes 3. Who else? Yes. Okay, so what we are going to do next is we are going to work with Saga, okay? And in Saga, so here in the processing tool, so this is the processing tool, and then here is Saga. You are going to look for the terrain analysis, hydrology, and then here we are going to use the field sinks of 1 liu, okay? But since this is too many steps to find this, you can also type field sinks and it will bring you field sinks of 1 liu. I say, okay, you want to do the field sinks, I mean what you want to feel all the pressures on your dam, okay? And that's great. So where you can store as a temporary file, that it will be the step that I will do, but since you are learning on this, we are going to save it, okay? So say save to file. So here the field them will be saved to file, and it will be called HTM GTM2 com UTM field. Okay, so this is the field them, and is that file. And what is that file? That file is that file is a raster file, but of Saga. This is the Saga format for raster file. Okay, so we can, okay, so with that we can store it, and then we can run. With that we can store it, and then we can run. And then it can take some minutes, doesn't take so long. Yeah. Okay, this tool actually fills the depression. I mean, what is a depression? Okay, great question. Let's go to paint. Okay. So imagine that you have a basin. Okay, you have the river, and then this is the basin. Okay, so the theory says that you have the runoff will be here, will be running over all the slope, well, above surface, and then it will reach the stream. Okay, this is what it says, the theory. Okay, but since this is a interpreted elevation, so this is actually not a exact digital elevation model, and then no digital elevation model actually is true image of the elevation. Okay, so you might have this. Okay, you might have this. Okay, you might have a sink. Okay, and what happens with that sink? So if I have a runoff, instead of reaching the stream network, actually it reaches the sink, and then you don't have flow anymore. Okay, so you have to fill the sinks. I mean, you have to fill those sinks, you have to fill them in order to for the algorithm to be working as desired. Okay, so this is what the field sinks does. Okay, so here I have my, for example, I have my field sink. This is my field sink. I can also have flow directions and also have watershed basin, but these are the raw basin. I mean, not the ones that we want to define. Okay, so but still can recognize some basins. So this is the field. It's actually the same. I mean, it's close to the same. You won't see much difference among them. Okay, great. So we are going to do some cross sections of this dam. Yeah, of this dam, and as well as of the original one. Okay, so of this and this. How we are going to do cross section of them of the digital elevation model? We are going to plugins, we are going to manage and install plugins. And then here I will be manage and install plugins, and then we are looking for profile tool. Profile tool is a plugin that brings you really nice stuff on the to make cross sections. Okay, it's kind of it's on version 4, so it's really an all it's really an all plugin. Okay, and I have used that from QGIS too, as I remember. So, and this is what you are going to see on terrain profile. So this is the profile tool. If you are here with me, please type if you are here with me, please type yes 4. If you are here with me, please type yes 4. Okay. Okay, so here what we are going to do are cross sections, but first we want to add the layers that where we are going to do the cross section. For example, I'm going to use the field one, and then I'm going to add layer, and then I'm going to use the original one, and as well I'm going to add layer. Both layer and on are red, and this is something that I don't want because I cannot make the difference. So I'm going here, you can change color to this, and then here I still don't like the red, so I can change color to this. Okay, and then I'm going to for example, for any, I'm going to do a cross section over this gully. Okay, so here, okay, so I just go here, right click, right, wait, there is a trick here. Okay, I go back here to the profile tool, and then if you see the cursor change to a cross. So when it changes to a cross, it means that I can do the cross section. So I can go from here to here, okay, and then, well, if you see, it's almost the same, but I do, okay, right click, but I can, if I do closer to the river network, okay, in this there is no different, there is not much different. Let's see close to the discharge point. Okay, here we see some difference. So I go from here to here. Okay, there are not much difference here. Let's see here, from here to here. Okay, and then double, I mean, if you do right click, actually you are going to delete what you have done, but if you do double click, you will end up your cross section. Yeah, and then here we can see how the field sim has changed the digital elevation model in order to fill those things and create elevation model where all water drains to the discharge point. Okay, great. So this is the profile elevation. This is how how you show, how you see what this algorithm has done to the digital elevation model. Okay, so this is for that. And then we are going to do some classification of the rivers according to the Strahler order. Okay, so what is that? Okay, so we are going to define a Strahler channel network, but the channel network has an order. Okay, so what does it mean? If you have a channel that has no tributaries, so this will be of channel 1 and this will be of channel 1. I mean, any channel network that has no tributaries will be of number 1. So when two number 1s connect each other, create a number 2. When two number 1s connect each other, will be a number 2. When two number 2s connect each other, creates a number 3. But when the number 3 connects to number 1, it is still a number 3. I mean, it won't change. Okay, a number 3 needs to connect to another number 3 to get a number 4. Okay, so you need 2 of one number in order to create the other number. I mean, you don't need, I mean, if you have some different numbers, actually it won't create a new one. Okay, so this is how the channel network is created, and how the Strahler order is an attribute. Okay, so what we are going to do, okay, what we are going to do is we are going to do, okay, we can close this of the cross section. We can go back to our processing, to our toolbox, and then we are going to do Strahler order. Strahler, that is Strahler order. Okay, so here this is the Strahler order. Okay, Strahler order, and then we are going to do the Strahler order not from the original one but from the filled one. Okay, and then we are going to okay, so this is the filled one, and then we are going to create this. We are going to save that to the concat fill and then underscore Strahler. Okay, so this is from Strahler. Okay. Strahler. Okay, so we can do run here, and then we are going to see the Strahler option. Okay, so actually this will bring us a channel network that goes from 0 or from 1 to 10. Okay, okay, so let's see what is Strahler. Here is my Strahler. I can put it this way, and this is your Strahler order. So this is your channel network, where for the values of that are black is 0, and for the values that are white is number 10. Okay, so I can show you this straddle order with better, with, okay, I can show you with a better color map. So right click, properties, and here on symbology, instead of single banded gray, let's go to single banded pseudo color, single band pseudo color, and then just select any, for example, blues, classify. Okay, again, right click, properties, instead of single banded gray, let's go to single banded pseudo color, and then let's do classify, or select any color map, blues, select classify, and then apply. Okay, so this is our channel network, but as a raster file, as a raster format. Okay, we can play around a little bit with that. Okay, so we are not interested, for example, in our case, in getting the 0 value, the 1 value, but we are interested in seeing the values that are even higher than 5. Okay, so we want to see the orders that are higher than 5. Okay, so we are going to do that. So we do right click, and then we are going to do a, well, in vector we can do a filter, but in uh, in raster we have to do a raster calculator. Okay, so how we are going to do, here we go to raster calculator, we go to raster, then we go to raster calculator, we get the straddler, but we want the straddler that are higher than 5. Okay, sorry, higher and equal, but higher and equal is actually this one, than 5. Okay, and then this will be stored as here on raster of session 3. Sorry, the other one I stored in session 2. Sorry, so I create here a RST. Sorry, I have been storing that on session 2 in RST, and this, how it will be called, it will be AST GTM2 com UTM field, and this is straddler 5. Okay, so this is the straddler 5. Okay, if you are here with me, please type yes 1, yes 5. Is there is no I mean, in this case we are just playing around with the straddler one, with the straddler. However, in later on, yes, we can do something with the threshold, with the accumulation threshold. Okay, but right now, no, this is just defined by the computer, where it defines 10 straddler order for your 10. Okay. And I think that there is one question: how can you save the profile from profile tool? We are going to do that the next time, because in this exercise we do this twice, I guess. Okay, but there is an option to save it as PNG, I guess. Okay, if you are here with me, please type yes 5. If you are here with me, please type yes 5. Okay, so we do okay here. Okay, and this brings us another them where we have only the values that are higher, where we have values that are higher than, the values that are higher than 5 will be true, so it will have a value of 1, and the values that are lower than 1 will be 0. Okay, so but this is kind of not practical for our purpose, so here the 0, we can do this, we can go to the 0, the square here, and then we say okay, here we go to symbology, and then pseudo color, single band pseudo color, classify by by continuous. Okay, apply. And on this one that is a 0, we can apply some opacity of 0. Why? Because we want that the 0 will be transparent. Okay, so this is, yeah. So if I take this out, if I add on Quick Map service a Google satellite or Google roads or whatever, it will show the channel network and the elevation model, and then you will see how is defined your channel network. Okay, I will do it again. Okay, this is the Strahler 5, so we go here to single band. It was we can go to unique values. Yeah, we can go to unique values, it will be better, and then we classify, and then we have just 2 values because it has 0 when it's not higher. The Strahler was lower than 5, and it was 5 when it's higher than 1 when it's higher than 5. But this value of 0, actually I will make it transparent because I only want to show the values that are higher than 5. Okay, and then I can go here to Quick Map service, Google satellite, and then I can see my channel network and the channel network and the satellite image. Okay, if you are here with me, type yes 6. Okay, why we do have 1 and 0? Because on the raster calculation we have the sentence is like if the raster is higher than 5. If the raster is higher than 5, only has 2 results, whether it's higher or it's not higher. When it's higher, it will have a value of 1, and when it's not higher, it will have a value of 0. Yeah, there are several orders because it's order 0, 6, order 5. Bigger than 5, there is the 5, the 6, the 7, and 8, and the 10, 9, and the 10. There are many orders here. Okay, but this is just to show, this is a way to show you the this this is a way of showing you the this procedure. If you, but if you are here, please type GIS6 so I can keep, because there is other way to do this as well. Okay, GIS6 if you are here. GIS6 if you are here. Okay, great. So there is other way to do that. Okay, how we do that? So we can go here to processing, and then we can do this. Well, there are many ways to do that. So we can do the channel network and drainage basins. Channel network and drainage basins. So it's this one, channel network and drainage basins. Okay, so here we have the field. It has to be only the field. This is the straler. No, it has to be this one. Field. It has to be field. This is a common mistake that we usually do on this. So we actually took them that was not the right one. Okay. The threshold here, for example, if we want that to have the channel network of value higher than 5, we are going to put 5. But if in our case we want the channel networks of values higher than 8, okay, and this really belongs to you and your criteria. For example, if you see here, I see on this basin that this is higher than 5, okay. However, here actually this is not of my, okay, here this is not of my interest, because it's really I see that there is few water that can go through this gully. Okay, so I will be interested, for example, in this one. So if I look for this value, this is here. If I look for this value, this is 7, for example, or maybe 8. Okay, that is why I want this, because, for example, if I use this and say, okay, here, yes, is where I say, okay, maybe, yeah, the channel network that is of my interest is the one that is related to this, because I assume that it has more water, or water is more continuous over the year. Okay, great. So that's why when I do this, okay, so when I do this, I select 8, and this is field. Okay, this is just a field. The flow direction will be stored as save to file. Let's go to session 3 raster, and it will be called flow dir. Flow dir. Yeah, okay, so I don't want the connectivity, I don't want the straler order, I don't want the drainage basin, because this is drainage basins are rasters. What I want is the channel, because in this case, this channel, if I save to file, this is a shape file. So this is Rios Rios UTM, because Rios is Spanish of rivers. And then as well I want the drainage basins, because this is as well, this is as a shape file, save to file, and this is on session 3 shape, and this is cuencas, that is basin in Spanish dot shapefile. Okay, so if you are here with me, please type yes. And junctions, actually I'm not interested in junctions, because junctions are identify the points where the two channels connect each other, but I'm not interested in that. If you are here with me, please type yes. If you are here with me, please type yes 7. Yeah, okay, there is another procedure that is watershed basins. Okay, that one has a threshold, channel threshold. Okay, so actually it defines the number 1 as the points where it has the a drainage area higher than this value. Okay, yeah, this is a defined order. You can play around with that, and I think that in some tutorials we do that as well, but in this case it's just something defined by the computer. Okay, if you are here, please type yes 7. If we are here, please type yes 7. Okay, so we run this. And then we wait. Okay, great. So here we have some results that are interesting ones. Okay, first, rios, let's say zoom to layer. So this will be our rivers that are from 7, 1, 8, 9, 10. Okay, then we have the basins. Okay, and then we have the flow deer. The flow deer is another type of raster that is show you from which is the direction of flow. Okay, great. So till this point we are going to do something very practical, and that's it. We are going to store all vector files. We are going to group them. Okay, group selected, and this will be vector. And let's see that all the rest will be group selected, and this will be raster. And the Google satellite I actually do not insert into raster because this is kind of background map. Okay, And why do I do that? Is because, for example, if I want to turn off all rasters, it will be like that. If I want to turn off all vectors, it will be like this. If I want just to show you the point hydrometry, or like the rivers or the rivers here. For example, here for rivers, we can do properties. Since we have categorize by order, classify, and then we have just 1, 2, and 3. Why? Because we have cut all the other 7 ones. So this will be number 8, 9, and 10. And then you can even do colors and apply. Okay, I do it again. Right click, properties, here from single symbol to categorize, here to order, here to select any blues, for example, classify, apply, and okay. Okay, so this is how you get the different structural order in the definite basin. Okay. Now I mean, if you have seen this, you have the basins, but you have the basins for all the, I mean, from the maximum basins that you can define. That this is like the maximum basins. However, what we are going to do now is that we are going to create a basin, but just for this discharge point. And how we do that? Okay, so we are going to do a catchment area. We are going to do a catchment area raster, and we are going to use the field one. The field, we have to use just the field one, and the method will be deterministic 8. Okay, the method will be deterministic 8, and in our case we are going to use just a temporary file. Okay, there is no problem to use a temporary file. It's kind of very practical, so we do that and we run, and then we use our temporary file. Okay, and with this catchment area, actually we can define certain basins, defined basins. Okay, okay, so that's it. Okay, that's it. Well, we can see here this map is beautiful. Okay, but first, if you are here, please type yes. If you are here, please type yes 8. If you are here, please type yes 8. If we are here, please type yes 8. Okay, so we can do some styling here because this is something similar as we have done with the Strahler order, but this is in the end is a catchment area. So what we are going to do is we are going to properties, and then we are going to single band pseudo color, okay, and then we are going to do a quantile, okay, okay, quantile here, okay. So if we do apply here, this will show you all our catchment areas, okay. Or we can do equal interval, classify, apply. Yes, well, we can do continuous, classify. Well, so this will show you, I mean, how are our catching. I mean, quantile is kind of the best one, classify. However, I have to do more classes. Okay, apply, or maybe less, 4 only. Or maybe we can start with 1 million with 10. I mean, in here this is area because this is catchment area, and then if we start with 1 million square meters, that will mean that we are starting with 1 square kilometer. Okay, so apply, classify, continuous, classify, continue. Oh, sorry, only continuous. Equal interval. The problem is that with quantile, actually it takes from the first one. Okay, so continuous. Okay. Yeah, well. So, yeah. So what we are going to do is that we are going but this is not the point. Yes, it's for the point that I have chosen. I mean, no, this is, I mean, this catchment area is for the whole, this catchment area is for the whole area. But if I want to, if I go here to the point that I have chosen, and then I go with my identify features, I select my catchment area, and then I will see that the area of this, of the basin related to this point, will be this one, okay, in square meters, okay. So, and then if I go downstream, it will be higher. I mean, it will be always higher as we get downstream. Okay, great. So what we are going to do now is we are going to use another tool that is called upslope area. Upslope area. And here on upslope area, what we are going to do is we are going to select the x coordinate, the y coordinate, okay, and then this will be of our field. The upslope area will be the method will be deterministic 8, and this, the x and y, will be the ones that we have inserted before. So the x and y will be of our txt file. Of our txt file will be these ones. Okay, this will be my x. Okay, and this will be my y. Okay, I open this with Notepad, but for you, you can open that with WordPad as well. So I will do this with WordPad. Txt file. So this will be my x, and this will be my y. Okay, great. So this is with the field 1, this is deterministic 8, and this we are going to store this as save to file, and this is will be called on session 3, this will be called upslope area in UTM. Okay, this will be upslope area on UTM. Great, so let's do it. Okay, if you are here with me, run it. If you are here with me, please type yes 9. I have some questions here. Nobody. Okay, right now, okay, you will see which will be the product of this because this one will actually give you the basing for this point. Okay, while the other ones give the complete basing. Okay, so let's run it. Okay, let's run it and type yes 9. Please run it and type yes 9. Okay, so I run it, and then you will see which is the um, okay, here, okay, this is the here this, okay, the upslope area. So we say zoom to layer. This is the basing for your discharge point. Okay, this is the basing for your discharge point. Okay, you see, this is the basing for your discharge point. However, yeah, this is a raster, so you might need it as a shapefile. How you are going to do that? Okay, in order to do this, what you are required to do is, yeah, what you are required to do is to polygonize this. Okay, so in order to do that, we are going to polygonize. Okay, polygonize. Okay, so with that we convert a raster to a shapefile. Okay, with that we convert the raster to shapefile, where this is absolute area UTM, yeah, and the result will be a shapefile that it will be absolute area UTM. So this will be saved to file, and this will be a shapefile, and this will be upslope area UTM. Okay, great. So with that we polygonize this. Okay, and this is the result. So we have the raster file, but now as a shapefile. Okay, so where we have the polygon of our shapefile and the outside polygon. Okay, if you are here with me, please type yes 1. If you are here with me, please type yes 1. In this, um, in order to do this, slope is actually slope and orientation is actually implicit in the procedure, but however, it's not an input of of our analysis. Okay, but this, I mean, in order to define any channel network, you need to slope, and from the slope you need the flow direction. Okay. Okay, so we have a shapefile that is the, okay, I'm going to bring this upslope area to our raster file and the catchment area as well to the raster file, and here on my slope area I'm going to do this with a pencil. Okay, why I have to do it? Because I do not need this. Okay, I only interested in the polygon of the basin, but I'm not interested in the polygon outside the basin. So I am going to, okay, first what I did with the pencil, and then with the selection tool I just located this, and then I will delete the selected. Okay, again what I have done, I came with the pencil, I selected what is outside, and then I deleted. Okay, and with that I get the basin for my discharge point. Okay, so with that I get the basin for my discharge point, and then I can show you this. So this is the basin for my discharge point. I can save my changes, I can get out of the edition, and then I do double click here because I want to show you, for example, a dashed version of the polygon, so you can see where is the polygon and how is the digital elevation map on this part. Okay, great. Well, we are going to do something here. We are going to do some, how say, we are going to clip the raster to the extension of the basin, and then we are going to do the slope basin, the hillshade, and other basins, other then we are going to do other stuff here. Okay, so I hope that you are following me, and say cut raster, cut raster, raster cut, raster cut. Okay, better. Mask. Let's use mask. Okay, clip raster. It was clip raster by mask layer. Okay, so everybody, clip raster by mask layer. So we are going to use the fillet one. Okay, don't confuse. And then we are going to use the mask layer will be the upslope area UTM. Since those are working on the same system of reference, there is no need to do any transformation. Okay, and that's it. And then we are going to, and this will be a temporary. This will be a temporary file. Run. Close. And this will be, if you see, this is the original and this is the clip. This is the original, this is the clip. Okay, and then the clip is as well on raster. Okay, so we have only what we have is the DEM file, but just for the slope area. And then there is other issue that here you have a channel network, but the channel network is actually not only for your basing area, but is even of a wider extension. So we are going to clip the rivers to the area of your basin. So here we go to extract clip layer, and this will be Rios UTM, and the extent will be clip vector by mask layer. Clip vector by mask layer. The input layer is clip, and this is upslope area, and this will be save to file, and it will be Rios UTM cut basin. And then what we have in the end is this, where we have the rivers just for the basin. Okay, what I have done is this upslope input layer will be Rios, mask layer will be upslope area, and then we save it as the save to file as this one. Okay, and then if you are here with me, please type yes too. If you are here with me, please type yes too. Okay, great. So finally, for this part, what we are going to do is we are going to use we are going to do some, for example, we are going to do a slope uh, on raster analysis. We are going to do a slope map of the field, okay, of the field, no, of the clip, of the clip, okay, of the clip. We are going to do a slope because we want to see how is the slope, and it will be a temporary file, okay. You can do it as a permanent, but it will be a temporary file. So, and then what you get is a slope, and this slope is of as a degrees. So this is degree as a degree, so this is a raster of slope. And as well we can do hill shade as well, hill shade of Jedal. So, and this is as well from the clipped run, and this is a hill shade of our raster. And there are other things that I can do. This slope, hill shade, Jedal, slope, we have roughness, and then we can do the slope, the hill shade, let's see the roughness as well of the clipped, and this will be a roughness factor, okay, and that's it, okay. So we are going to close our for this, okay, and just something final on this is, what if we want to do contours, okay. I'm going to bring this and this to my raster file, and then say, okay, I want contours of contour elevation from my raster file, okay. This is will be as well from clip, and in order to get contours it's really easy. Just have to have contours, contours, contour from Jedal, because this as well you can do it from raster. This will be from the clip, and the interval will be 50, I guess. Yeah, it will be 50. No, it will be 100, I guess, because you have a really extreme change on elevation, and the attribute on the shapefile will be elevation, and that's it. And it will be a raster file, or we can save it to files, and this will be contours as UTM. We can do run, okay, and then we have here the contours every 100 meters, okay, and this is it. If you are here, please type yes 3, because with that we close this, and then we have to save our project, and then we are going to do to the last part of this class, that is the statistics. We are going to do some statistics, okay. So yeah, if you are here with me, please type yes 3. If you are here with me, please type yes 3, and then save your project, save your project, okay, where you are going to save it in session 3. Create another folder that is called QGIS, and then here this will be part 1. Okay, part 1. Okay, I have to say you something, that we have been giving this for around 1 hour and a half. The next part is much shorter, but we are going to give 10 minutes pause. 10 minutes pause. So we are back at 7:38 Amsterdam time. Okay, 7:38 Amsterdam time. Yeah. Okay, so 10 minutes of pause, and then we are back. Okay, we are back. We are back. Okay, so we are going to create a new project. Yes. Okay. So, and in this new project, what we are going to do is we are going to open the we are going to open from what we have done in the previous part. So this is GIS and water resources. On the raster file, no, not yet, not here. Well, we are going to do yeah, we are going to open from the course material the AST Comcat, okay, this one, and then we are going to open from the shape files that we have done in the previous the upslope area UTM. Okay, so this is what we are going to open. From the previous part, we are going to open the upslope area UTM, and from the other part, we are going to open the digital elevation model. Okay, so what we are going to do first, we are going to see something about the statistics. So here on properties of the raster file, you can see the histogram. So you can compute the histogram, and then you can see, for example, all the values that are presented on your or values and how many times those values are presented on your raster. Okay, so this is a kind of a very distributed raster because it has values that range from 0 to 4600. Okay, great. But what we are going to do is we are going to do zonal statistics. And what is zonal statistics is that this is a raster, but this is a whole raster, but we want to do a statistic just in this part. If you want to do this, you can do zonal statistics, and this is comes from raster analysis for QGIS. Okay, and then say zonal statistics, and then we are going to the statistics of the upslope area to the raster area, and this will be called stat. Okay, this will be the prefix. Okay, and then we create a temporary layer. Okay, so we are going to do the statistics of the elevation but inside the polygon. Okay, this is what we are going to do now. So this is the upslope area, this is the raster layer, and then we are going to do the raster band and the statistics inside the polygon. So we do run here. Okay, and then we see we are going to get another raster, that is another shapefile that is the same as the original one. This is the same as the original one. However, here on the attribute table, we are going to see that the count, the cell count inside this raster is this one, the sum is this one, and the mean is this one. And this mean is the mean elevation of the basin. This is the mean elevation of the basin. Okay, great, great. If you are here, please type yes 1. The histograms, if you have a raster of elevation, the histogram is an histogram of elevations where on the, okay, let's deal with this. Okay, so if we do properties here, this is the elevation and this is the frequency of this elevation in the raster. Okay, so for example, here we have this elevation, and then we have that this cell is repeated this amount of times in the raster. Okay, and here actually you cannot select, you cannot define the interval. Okay, so okay, you can define the minimum and the maximum. However, you cannot define, for example, ranges in order to say, okay, let's divide it from 3000 to 4000 into three ranges. Okay, so if you are here with me, please type yes 4. If you are here with me, please type yes 4. Okay, great. So the numbers that are here on this table is, this is the count. Okay, what does it mean, the count? For example, let's say, so here we have a raster is in fact a number of pixels. Okay, so we have a lot of pixels here. Yeah, so the number of pixels that are inside this polygon is what it appears here in count. Okay, in count. The sum of the values of those pixels, because each pixel has a value. So let's say, for example, this pixel has a value of this, okay, and every pixel has a value. Okay, that's it. Okay, so the sum of this is what it appears here. Yeah, and the mean, so that means that the sum divided by the count is this one, and this is the mean elevation of the base. Okay, so here in Sonar Statistics we are going to create two more layers, and the first and the other layer that might be of your interest, it will be a new field that it will be area, because you might want the area of your raster, and in order to get the area is just how to say this symbol, an area, and this will be an integer, according to that is an integer, yes. These numbers, this number is actually of no use, but this one, yeah, is useful when you want to define a base, because they say, yeah, the mean elevation of basin is that. Okay, this is useful. Okay, and this can be input for some parameterization of your basin. Okay, the area, okay, with that we create an area. Okay, and this is the area, and this is as well important. And then we can get the perimeter, so we can do the perimeter, and as well as the area, this is just dollar, I don't know how do you call it, this dollar perimeter is perimeter. Okay, so this is the area in square meters, and this is perimeter in meters of your basin. And then if you want to see the main slope of the basin, because you want to see the main slope of the basin, okay, I will get out of this, and then I will see, okay, here let's see, slope. I get the slope. I get the slope from GEDAL. Yeah, I get the raster of slope as a temporary file. Don't worry. I type a slope. I get the raster slope from GEDAL, and that's it. Okay, I get a raster of slope, and then I get the zonal statistics again. Yeah, and my input layer will be zonal statistics. Yeah, and this will be slope stat. Okay, so here we have the slope stat, and it will create the count, the sum, but in my case I want the mean only. Well, I will work with all of them. Yeah, zonal statistics. Okay, so this will be the slope, and this will be slope stat, and it will create a temporary layer. Okay, zonal statistics. Yeah, it will have a slope from the slope raster. Okay, so I can create this. Okay, and then I will have another zonal statistic, another one, but in this new one I will have the mean slope, because as well I have the count, the sum, and the mean. Okay, and then I get, okay, I have too much information here because I am more interested in the area, the perimeter, the mean elevation, and the mean slope, but I'm not interested in this. This is useless for me. How do I get rid of this? Okay, I can get rid of this by editing this and then selecting this, delete field or Control L, and I say, okay, I don't want this, I don't want this, I don't want this, and I don't want this. Okay, so I can take those out of my shape-file, and then I get just the mean elevation, the area, the perimeter, and the slope. Okay, I can get out of the editing, and that's it. So this will be everything for today here on this course. And project save as part 2, session 3, QGIS part 2. And we hope we can see you in the next class when we are going to do more hydrological stuff on this basin. Okay, if you have any questions. Yeah, for example, there is a question that say if it's possible to calculate the concentration time. You can calculate the concentration time, but depending on the parameters that you need for that formula. For example, if you want the mean slope of the basins, actually you have the mean slope of the basin. Okay, if you have the total length of your channel network, that will be also possible. For example, in Rios UTM cat basin, yeah, I can do a zonal statistics as well. Statistics. Okay, let's say but for vector statistics, basic statistic for fields. No. Okay, here on Rios UTM we can open an attribute table. Here we have the length, so I say basic statistic for fields. So we see we are going to calculate the length and then say, okay, this the maximum size of the channel network will be the sum here. So this medium sum, this will be the sum of the channel network. Okay, so it really depends on the it really depends on the formula that you need for the that you are using for the concentration time. Okay, okay, if everything is okay, please type yes 5 and we say us goodbye and see us on the next class next Monday. Okay, please type yes 5 if everything is okay, and we see us next Monday. If everything is here okay, we close. Okay, have a